Alright, well, I finished boring these out this morning. The last two went a lot better than the first two. They weren't... Which one was the last two? I know I did that one last. Two of them cleaned up all... Yeah, those two. They cleaned up all the way. And these two still had wear spots in them, but I don't need to go out that far so we can fill that with weld. But because I'm going to be waiting on Coulter parts anyhow, I'm switching gears and I'm going to leave those where they're at and start working on the tail wheel so that I can get this done, so I can get this thing out of here for the week and just work on the Coulter. So I'm going to get my lift arm pulled off first and we'll get that bored. Hopefully. It looks pretty bad. Hopefully there's enough meat in there to bore it. Otherwise we might have to cut that weld and... Well, we'll see what it looks like. It might just be easier to cut that damn weld out and just make a new sleeve completely. But we'll get it apart and see what it looks like. Well, I got good news. This job's going to be a little faster and cheaper than I quoted you. As it would turn out, I don't know if it's factory, because that hole's got some weird wear patterns in it, so it could have been fixed at some point. But either way, either from the factory or at some point, I could tell you if I went and looked in the parts book to see if there was bushing in this. But this has hardened bushings in it. I find it odd that they're hardened bushings. You'd think they'd use brass bushings, that way the bushings would wear and not the part that I'm about to show you. But either way, the bushings are in there. There's bushings in there. The stupid part is they had them installed in such a way that they were covering up the damn grease zerk. So you weren't getting any grease in there. It was just coming out past the damn bushings, which was kind of retarded, if you ask me. So I pushed them out so I could clean the hole up. This one's chowdered up a little bit, which I don't think is because of use. I think it's because of a piss poor install job. So I'm just going to reuse those because there ain't nothing wrong with them. They're hardened, so the bushings are harder than the steel they were in, and they're harder than the steel they were riding on. Makes no damn sense. But because of that, the pivot shaft is a little foobarred. And basically the only way to fix that is to weld it up and grind it off about as round as you can get it. So basically, since I got them bushings out, I'll go through, weld that up, grind it off, and get it, just keep sliding the bushing over it until it feels decent and put it back together. Which is faster than having to bore it and make a bushing. But it's just, I find it hard to believe that they would have done that at the factory, because that's kind of bass-ackwards of how you want it to work. You want the bushings to be the wear point, not the damn axle. But I don't know. Oops. Well, that's a good way to break it, but it's fine. So anyway, I guess I'm going to get set up and start welding. And a little bit of time and patience with a grinder later, that's what you end up with. Like I say, it's not perfect by any means, and fixing it like that, it never will be, because you can't make it perfectly round. But that's a damn sight better than what it was. And that weld is going to be harder than the steel that you laid it on, just by its nature, so that'll probably never wear out again. At least not in my lifetime. And before anybody pipes up and says, "You're going to make it brittle welding on it like that, now it's going to snap off." No. What makes steel brittle is when you go welding on it and then you quench it and it changes the crystal structure of the steel. I welded on it and now I'm going to let it come back down to ambient temperature on its own and it should be alright. The only thing that would have been better is if we had a forge I could have thrown it in, preheated the whole thing, then welded on it, and then let it come down to temperature. But short of having a forge, and you kind of could have done it with a torch, but you can't evenly distribute the heat with a torch. You're going to have hot spots and cold spots, and that could do more harm than good. So it's not really worth screwing with. But this ain't the first time I fixed stuff like this. I fixed a plow axle on a 2-bottom like this, and it's still going strong, so it ain't going to break. Guarantee it. So anyway, I did say I was not going to make a bushing, but I really don't like them bushings, and even with the way they are out here on the virgin part, I'm not going to touch it, but out here on the virgin part of the shaft, they're still loose out here, so I don't think those things are right. I think that's something somebody just stuffed in there. So I'm going to make a one-piece solid bushing so that it has the entire bearing surface to wear on, and then we'll punch a grease hole in it once we get it pressed in. So guess we're going to get some lathe time in if I could find some material that I can work with that's the right size. But first I think it's lunchtime. Alright, so I found a hunk of Schedule 160 pipe to make a bushing out of. Normally in a situation like this, what you would do is you'd turn your OD, press it in the part, and then bore your ID. But because that thing ain't gonna be perfectly round anymore because I welded it, and because it's just a lift, there's nothing precision about that to begin with, so it can be just a tad sloppy. It ain't got it. It ain't like we're gonna take this thing down the road 150 mile an hour and it needs to be super precision within the thousandth of an inch. So what I'm gonna do to just avoid a bunch of extra machining steps and a bunch of extra setup steps, I'm gonna go ahead and bore this thing a tad bit oversized. That should be 1.5 inches, so I'll bore it like 1 inch 550 so that I got a little oversized. That way when you press it into the arm and it shrinks, it'll come down and be roughly right. So I'll go ahead and get the inside bored out. I'll drill it 1/2 inch and then throw a boring bar in real quick and just bore out the extra little bit. And then I'll go ahead and turn down the ID, or turn down the OD to the right size, and then we'll press it in and throw it back together, and this part should be done. Yeah, still a little fast. I like that a little better. Well, I'm not even really going to have to bore it oversized. To make sure everything was alright, I just shoved the axle in there and it fit just fine. So basically the drill made it slightly undersized. It made it 1 inch 490. So I'm just going to bore it up to 1.5 inches even, which that's typical of a drill bit. Very rarely do they actually drill on size. So I'm just going to basically go use the boring bar to clean the hole up for all intents and purposes. So really just going to go in there and kiss it. can speed up a little bit now. There we go. Alright, so this measures roughly, because it's not perfectly round, roughly 1 inch 90 on the OD, and the bore it's got to go in measures roughly, because it ain't perfectly round, about 1 inch 765 ish. So got to take roughly 25 thou off ish. So yeah. And I already touched off on the part, so alrighty, well, got the new bushing all pressed in there and everything. I think real quick I'm gonna weld this up and grind it back out flat. But other than that, I had to, there was a couple, once I'd started fitting it, there was a couple high spots in this I had to hit with the grinder. But now now it slides together like it belongs that way, so should be good. Well, you saw how bad it was before. It was damn near leaning hard enough that it was hitting this side of the bracket. And now thing hardly moves. Actually, when you move this, it moves the whole deal, so that's real nice. And I gave it a shot of grease, and it took grease just fine, so that part is good to go. Nice. Right there where it lays on the roller, I welded that up and ground it back off flat. So next weekend we have to pull this piece off and pull that roller out, and probably have to bore the holes out oversized that the pivot pin goes through and make a new roller, because that one's kind of effed up. And with that, the lift mechanism will be pretty well kosher, because everything back here is pretty decent. So anyway, I think that's it for today. I'm going to go down and get to 1600 warming up so I can get this thing out of here, because I probably got half hour, 45 minutes of cleaning once I get this thing out. So that's it for today, and we will catch you guys tomorrow or Tuesday, depending on how things go. So anyway, on to the next day. Okay, so back on the plow project for this afternoon. So while I'm waiting for shit to show up, I'm going to work on these clevises for the cushion springs on the Coulters. They're all pretty rough, and the pins are junk. And I was initially going to bore them out oversized, put a top hat bushing in there, and put them back down to standard, but there's plenty of meat here to work with yet, and that's a lot of work for something that it's kind of unnecessary. Basically what I can do, and the holes are actually damn near wallered out to 3/4 already, but to clean them up, I'm going to run a 3/4 end mill through there and just get 3/4 pins for them to tighten them up that way, rather than go through the work with the top hat bushing and all that, because that's going to be a shit ton of machining. So yeah, easy fix for this one. I feel weird. I don't have my hat today because I've been moving snow all morning, and it was like 16. Well, they were saying it was supposed to be 16 degrees out. I don't think it ever made it that warm. When you say warm and it's 16 degrees, but needless to say, I was wearing a stocking cap, and when I left the house to come over to Mom and Dad's, I forgot to grab a regular hat, so I feel weird. That never happens. Oop, whoops. Guess I didn't have that thing tight enough. Try that. There we go. And before I pull that out, I got to get a backstop on here so that I can do the rest all the same way. And that didn't clean it up perfect, but that little teeny tiny bit of slop in there with a 3/4 pin, you'll never notice it compared to what it was, because it was bad. So that's that part. And then we got to do the mating hole on the Coulter arms themselves. All right, so all the clevises are done. So now got to do the matching hole on the Coulter arm, which is easy enough. I'm so used to running this thing with the boring bar in it and back drive, I keep hitting reverse. And there's that. Well, here's your shot of Teeter for the video. Little girl getting big. She actually came out here on her own. I didn't have to ask her to.
Teeter, what you think? What you think?
I don't think much. Anyway, where'd I put them? Got my bolts from Points. Those came today. Dad got rod stock that I need for those pins. That actually showed up yesterday, but I was home getting ready for work. And all I'm waiting on is my 3/4 inch Clevis pins that I got ordered for the cushion springs. Those might not be here till Monday, because they said 3 to 5 business days, and I ordered them on Tuesday. So hopefully they'll split the difference and make it 4, and they'll be here Friday. But I don't have my hopes up. It's probably gonna be Monday, just because that's the way things go. So anyway, first things first, need to figure out how much I need to, or what I need for length on these pins. Damn, that's bad. I'm glad I decided to remake these things. Looking about like, hold on, I need 2 hands for this. Okay, she had to go out back and go potty. So anyway, 5 3/4. Insertion depth is 4 5/8. And hole is 3/8 from the end. And what I'm going to do is I'm going to measure how deep they inserted all 4 of them, and I'll find the average. Because it seems like a couple of these things were short enough I couldn't get a washer on there in between the yoke and the roll pins, and I kind of want to get a washer on there, so I'll probably actually take the longest one and use that dimension. So measure them up and start cutting. Okay, so I'm all set up. I'm zeroed off the end, zeroed off the back of the vise, yada yada yada. If this was a nice square part, you could, I got my center drill in because you don't want the bit to walk, but if this was a square part, you could slap all of them through with the center drill, put your hole, or put your center hole in, and then switch to a drill bit and slap them all back through again, because you're working off of a backstop, so everything's gonna end up in the same spot, except for this is round, so you don't want to lose your center, so you gotta switch tools and do all your operations without taking the stock out of the vise. Is what it is. Just something you gotta be aware of when you're doing this kind of stuff. And yeah, that's basically it. Okay, now the fun part is going to be getting the old pin out of the arm, so I can get it in the vise. I took it in the bandsaw and whacked the vast majority of it off, and I'm going to take a surface mill and get all that weld off there, so that hopefully just get on it with a hammer to punch and drive it out. So looks good on paper anyhow. Let's see if we can get you. That ought to work. This thing's fun because it throws chips everywhere. Zero out the knee. Not that there's anything precision about this, but it helps you know how big of a bite you're taking. Problem you run into is this arm was these holes weren't drilled, they were punched in a press, and it's probably damn near impossible to see on camera, but they must have hit it from this side down and it put an indent right there, so that weld is sunk down in a well. So when you try to get a little bit more of a bite out of it, you're starting to bite right here and you're starting to bite right here. So gonna have to do last little bit with a grinder, methinks. And we're ready to do some welding. Those actually came out really easy. I just took a grinder, a hard wheel on a grinder, and just kind of feathered the edge out around approximately where the pin was, since you couldn't see it anymore, and got it down flush with the bar stock that the arm's made out of, and then took it down in the press and hit it from that side and put about 20 ton on it, and it popped the weld and then just knocked it the rest of the way out with a hammer. So pretty darn easy. And then the winning insertion depth was 4 3/4. That was the longest one that I found out of the 4, so that's the one I'm going with. And I've got all the pins drove in to where the roll pin hole is going to be roughly straight up and down when the Coulter's assembled, so then they're all the same that way. But anyway, time to lock her together. about that? How about that? Way better than what it was. So that's done. And for all intents and purposes, they're ready to go back together, except apparently these are washers. This goes right here. I like so. And I thought that they were machined into the spindle themselves, but they're not. They're apparently a replaceable wear part. So that one is really bad. And that one is pretty bad. That's what they're supposed to look like. They're supposed to have that nice pronounced step in them. And then this one's damn near brand new, because this is that arm off of a later model plow. So it doesn't have the acres on it that the green ones do. But basically, I got this one good one here. And the whole reason I found this out was when I was driving the pins in, that one fell off. So it's like, hey, we can fix that. So this one and this one are good, so I got to make 2 more. I found a piece of stock that's the right size. Can't tell what that says. 4140 heat treat. Shit. Maybe not. Gonna have to go hunting again. I don't know if I want to be making it out of heat treat. I don't know. They would definitely not wear out. I have to see what Dad thinks, otherwise I'll go find something else. But either way, get a hunk of stock and just copy that guy, since it's pretty much new, and make 2 new ones. And for the guys that were back here when I first started this project and resurrected it back to usable condition last winter, or I guess it would have been last winter, early spring, either way. I had one Coulter blade that I couldn't get the bearings tight. I got them reasonable, but I couldn't get them where they should have been. That was this guy. And that's probably because that washer's screwed, because the bearings are supposed to butt up against that shoulder. So without that shoulder there's nothing for the bearings to go up against, and you run out of thread. So problem, solution. So that's going to be the project for tomorrow, and tomorrow we should be able to hopefully get them all put back together. So we'll see what we got for time. But anyway, we'll catch you guys tomorrow. Okay, making these spacers. I worked ahead a little bit just to get some of the boring stuff out of the way. Well, first off, it's a good thing that I'm making this out of that 4140, because I struck this thing with a file, and it does have I don't know if they case hardened it or if it's actually made out of a hardened steel, but it's hard. It's not like mild steel. Harder. It's not super duper tough, but so the 4140 was a good thing. I stepped the hole up to 1 3/16, and then I took a boring bar, that guy, and bored it out on size, because it's not quite inch. It's like 1 inch 450 something, and it's in some change. It's not quite 1 1/4. So I bored it that way it would be closer to the right size. This one's done already. This was my practice one. I still gotta check it back up in the lathe and clean the back off, but that's just what it's like after I parted it off. But I mean, they're pretty damn good. So I'm already set up to start making my next cut. I went in and touched off of this, which is already going to be flat because that's where I parted it. So this is already good. So I touched off on that, came over, touched off on my OD. So should be good to start facing everything off. Need to go in 70 thousandths to make the collar, and take a 1/4 inch off to make, or it's going to be a 1/2 inch total, but take a 1/4 inch off the side to get your 1/2 inch. So, that's not magnetic. Interesting. I guess we'll put you there maybe. But I've already moved over 25 thou, so and that should be what we want. One inch 750, and this should be 70. Good enough for what it is. It's measuring about 68. Yeah, I'm gonna call that good. So now back off a little bit. And we gotta switch over to the parting tool. Like so. And gotta true it up. Like that. And it needs to, oops, come down just a hair. And a little more than that. Like so. And then we set our depth. There's literally going to be just enough. So there's that. Lock her down. there we go. Pretty darn good, I dare say. Have a lot better than the one we're replacing. So with that, I think we're finally done making chips and we can start putting some shit back together. So, all right, this is the last one that I gotta assemble. Well, I've only been putting the arms together. I haven't got the bearings or blades or anything going yet, but baby steps. And since I'm waiting on my new pins just for assembly purposes, I've been putting them together with some 3/4 bolts just so I can make sure everything's gonna fit right. And so far they are a shit ton tighter. But this is working out a lot better. For starters, when you tighten the spring up, it actually pulls the yoke out away from the arm, because when this is all, if the arm is tight up against the yoke, it shoves everything over here. Well, you tighten the spring up and it pulls everything out. So that was probably part of the reason before, when everything was still old and shitty, I couldn't get, there was 2 of them that I couldn't get washers and pins on, because everything was so wallered out and loose that, because when you tighten the spring, it pulls everything out. It took the whole arm assembly and everything and pulled it outside. Having this a little long is going to help a lot. I think it also should help keep that pin from shearing now. But one of them was this long to begin with, because I measured one. It was 4 and, what did I end up saying, 4 3/4. So one of them was already like this. But I gotta get that sucker loose. Well, that sucker was a fighter, but we got her off, so. Shazam! Just like new. So I guess, what time is it? Might have enough time to get 1 or 2 blades put together. Alright, so we are putting the Coulter back together today. Actually this afternoon, because it's almost 6, I guess this evening, because it's 6 o'clock. Nice way to spend a Friday afternoon. Not really, I hate packing bearings. It's one of my least favorite activities to do. But it is what it is. Also, just in case anybody's curious or needs to do this on their plow, the AGCO part number for these bearings, the sealed bearing with because these have integral seals made into the bearing, that part number is 7531251, or 7053, sorry. And the regular bearing, this would be the inner bearing, or I guess it'd be the outer bearing, and this would be the inner. However you want to look at it, this is the one that goes away from the hub. The other bearing is a 711507HE1. And then the race, the inner and the outer are the same. The race is a 711242. Just in case anybody's curious. But this is the last one I gotta do. I've been at it for about an hour or so. Got the others. Well, I did one last night before work, and then I got these left to do. Or had 3 left to do, so I got 2 done, and this is the last one, and yada, yada, yada. This is one of my new spacers that I made. The other one, the bearing tightened up nice and good, so hopefully this one does the same thing. Need a paper towel. Still waiting. I'll have everything except I'm still waiting on my Clevis pins for the springs. Those will probably be here Monday because that'll be day 5. Told you I wasn't gonna get lucky. They were supposed to call when they came in, so hopefully they do. These have already had I put new nuts in them when I had these apart last time, so no sense in replacing those again. You can get 2 or 3 good shots out of a nylock before they're worn out. Everything is just so much nicer with new bearings. They run so smooth, there's no growly, they tighten up good, it's just so much nicer. Now, like I did last time, this obviously was not something they would have done at the factory, but it's something I'm doing now because the key to keeping the bearings in these things good is keep the damn water out of them because the plow sits outside. So I ran a bead of RTV around here, and then I ran a bead of RTV on the hubcap to keep the water out of the bearing because the seal is on the back, so in theory that should keep the water from getting in the backside. But the Coulter's kind of pitted, and these mating surfaces are kind of pitted, so water can run down the Coulter and get in between there and fill the hub up, and next thing you know, your bearings are full of water. Which, if you do a good job of greasing it and keep that hub packed full of grease, shouldn't... I mean, no water is good water. If you keep it greased right, you should be halfway decent. But if you can mitigate it and just keep the water out completely, that's the better way to go. I may have to go down and grab a bolt because I forgot one broke. How the hell these bolts break, I do not know, because they're protected from rocks and shit because they're back in a recess. And it broke the head off of all things. It didn't break the nut. So I was confused by that, but either way, I think I got some of these spare down in the barn, 'cause I think I ordered extra. Wonder what size were those? 1.25 inches? No, they measured something stupid. They were like inch and... Yeah. Shouldn't need a washer on the bottom of these. There wasn't any before and they were alright. And there we go. That part's done. That is, there's not even words to describe how much better that is. They hang straight. Yeah, that was worth it. The only thing I'm still waiting on is, like I say, I'm waiting on my damn Clevis pins. It'll probably be here Monday or Tuesday, so... But anyway, just a quick point when you're setting up Coulters on a plow. Basically, you got two positions that you can run the shank in. Obviously, you can run it with the shank swung back or swung forward. When you're cutting stuff like sod that's going to be hard cutting and hard laying, generally you want to swing it back to get the Coulter closer to the moldboard. Plus, when you're doing sod, you're not going to have much trash, so you're going to reduce your chances of plugging, so you don't need the trash clearance. So you swing them around for sod so you get a better slice. When you're doing something with a lot of residue like corn stubble or wheat stubble or basically any heavy crop like that, you swing them forward to move the Coulter away from the moldboard to give you some trash clearance. And then I'm also, because these Coulters are so damn huge compared to because you could probably get away with 16s. I think these things are like 18 or 20. They're huge, but they cut nice, so I kept them. But because of that, I'm running the shank up basically as far as I can get it. Because you don't need the Coulter buried down as far as the moldboard is. All that's going to do is try to hold the plow up out of the ground. Although springers aren't that bad because it'll just collapse the spring. But generally, you only want the Coulter in the ground about 3-4 inches, just enough to cut the trash and start the furrow slice. And then the shin on the moldboard will do the rest. Speaking of which, I also noticed that I'm probably only going to get one more season out of these shins too. But we'll run them for what they're worth. They're still pretty meaty up here, but they're getting kind of thin, and they aren't all wore the same. This one's kind of bad. That next one up's not terrible. You don't really notice how bad they are until you get the new points on there, and that's like, woof. But anyway, back to the Coulter. So you swing the shank around forward to move the Coulter forward when you're doing heavy residue plowing. You only want to run it about 3-4 inches in the ground, which on this plow is probably going to end up being a little more than that because the Coulters are so damn big. But like I say, when you put it in the ground, the spring is also going to collapse some, and it'll hold the Coulter up to begin with. If they were rigid Coulters like what I got on my 4-bottom, it'd be a different story. But so you do that, and then as far as putting it in relation to the side of the shin and the side of the bottom, you want to hold it. You can sight it. To rough it in, you sight down here and you try to get it about 1/2 to 3/4 inch off the side of the moldboard. And then basically you almost have to stick it in the ground after that and see how it acts. So basically the next time I take this thing out to plow, I'm going to have to take a wrench with me and probably have to swing the Coulters one way or the other. Depending on how it plows, if I did a good enough job eyeballing it, it's going to plow fine. We won't have to screw with it, but basically, you want it out far enough that you cut the trash out far enough that it rolls better. And if you start the slice out this far, you wear the shin less because it doesn't have to work as hard. It's not shearing the soil off to lay it. The Coulter's already done part of the work, and basically all the shin is going to do is lift it and start the roll. That's why, like you see out west a lot, in the irrigated ground where guys are running 2-way plows or they're running deep tillage plows, they don't even run Coulters. The reason for that being the ground out there is usually so damn hard that if they run Coulters, the plow won't go in the ground. The Coulters will actually help lift the plow up, and they have a hard time getting the plow to go in the ground. So generally, if you do see them run one, it's only on the back bottom so that they get a clean furrow slice, and the other bottoms they run without Coulters. Or like down south, they run those switch plows, which are kind of like a 2-way plow, but kind of not, and they got those goofy square bottoms on them, and they swing back and forth rather than roll over. Those don't run Coulters. But basically, if you run a plow without Coulters, figure on doubling the rate of wear on your shins, because they're pulling double duty. They're both shearing off your furrow line and they're starting the roll. So basically you burn the edge of the shin right off, because they are doing 2 jobs at once because you're not running a Coulter. In our ground, you're never going to get away without running Coulters. A, we got too much trash and it would just wrap up around the beam and you'd be plugging the plow. And B, our ground is heavy enough that you need to start that. It's heavy, it's not hard, if that makes any sense. It's got a lot of clay in it. So, in our ground, you need to run a Coulter. For 2 reasons. A, because we got so much trash, you need to cut the trash up, and because it's just our soil type, you need to run Coulters. So anyway, that's basically your tutorial on setting up Coulters. Run them as high as you can, just enough to cut the trash. Keep them 1/2 to 3/4 inch out away from the side of the moldboard. And yeah. But anyway, with that being done, still have to tackle the Coulter on the drawbar, which this one, I got one off of a parts plow that I'm going to go see if it's in any better shape, because I was screwing with it earlier. Yeah. I have to get it apart and see what's wore more, the pin or the bracket. If the bracket's wore, I'm SOL, because we do not have the ability to bore that deep. We don't have the tooling, and our mill won't doesn't have, well, our mill would if we have the tooling, but actually it might not, because I don't even know if I can get the knee down that. If we had a boring bar long enough to do that, I don't think the knee will go down long enough or far enough, because you would be, that's probably every bit of 8 inches, so you'd have to have 16 inches down to have that and the boring bar and clear everything, and I don't think we got enough throat. So but I got one that might possibly be in better shape, and we can still knock the pin out of the shank and put a new pin in it to tighten it up too. So we got to do that. I need to get the points on. I was going to do that before I brought it in, but it was all stuck with ice in the bottom, so I had to melt off. So I just brought it in, and I'll put points on when I go to take it out. And have to pull the bottom section of the tail wheel lift rigging off and see what we got going on down here, and replace this roller and the pin that it's on. So that's what we got going on for tomorrow. And after that, I think we're pretty much ready to rock and roll. I can't think of anything else right offhand. Do all that, there really won't be anything that I haven't touched. Shit, I should have got new pivot bolts for the bottoms. That's what I should have done. But that's easy enough. I can get those and make them, and then those can be swapped out in like 5 minutes. But anyway, I think tomorrow I'm going to start another video, because this one's getting long enough already. So I guess with that being said, that's it for this one, and we will catch you guys on the next one.